Hello everybody, in this video I'm going to be talking about using the DS3231, which is an RTC, so real-time clock, and I'm using it with the STM32 microcontrollers. This uses I2c communication, and the specific microcontroller I'm using for this is the STM32 F407, but it should work with other microcontrollers. You just may need to change other STM32 microcontrollers, but you may need to change which pins the I2c is connected to, so the SDA and SDL. So as you can see on the screen, everything is in this header file. So this main is just really and truly just used to test and see the values on the debugger. So this is just variables for hours, seconds, and minutes, as well as the date, month, and the year. This is a structure to basically read from the sensor, and we've got I2c initialize, we've got a function to set the time, set the date, and in the while loop we use this function to get the time. We pass in the handle, and then we just read from it. And it's the same thing with the date. We pass in the handle and then we read from it. So if I go to the header file for this, we can see that there are some I2c functions. So this is used to communicate with the RTC. So it's for all of the I2c communications. So sending the start bit, the stop bit, whether I'm reading to the address or writing to the address, and what byte I'm sending to the RTC. I have this enum, which is basically a 0 or 1 if I want to send multiple bytes, or if I just want to send 1. This is used to read the byte back, and as I said, if we're doing multiple ones, I'll set it to multi-byte on, or if I'm doing just a single, then it'll be off. This function basically converts the BCD value to decimal, and I will speak about that when I quickly look through the data sheet. But basically, the RTC values you read to and send to, they're in BCD format. So when you're reading from it, you want to convert the BCD value to decimal, and if you're writing to it, you want to convert the decimal to BCD. These three functions were the initial ones I made, so I don't actually use them anymore. I just haven't removed them. But this is if you wanted to read the individual seconds, minutes, or hours. You could also do one for the date, which is very similar as well, but as I said, I don't really use this because everything is in the handle. Two functions, one to set the time, one to set the date. You pass in the parameters of hours, minutes, seconds, and for the date it will be the day, the month, and the year. Has a structure, which is what we use to read from the RTC. And lastly, there are two functions here, to get the time and to get the date. So everything's pretty straightforward. So if we go into the DS3231 C file, you can see I defined the slave address to be 0x68, which is the slave address of the module. We've got the I2c initialize, as we saw into the main header file, the main C file, where I called the I2c initialize, and this basically sets up all of the configurations for using I2c. So on this particular microcontroller, this STM32, it's on GPIOB, so I turn on the register for that. The two pins, as they're alternate functions, I need to configure the mode register for alternate functions, and they're located on PB. They are SCL and SDA for PB6 and PB7. We are setting the alternate function to use I2c1, and the output type register is set to open drain. since we're using I2c1, we enable the clock. And here is a software restart. I think in the datasheet somewhere it said, just to, toggle this pin basically, set it and clear it, and it just basically resets it back to maybe its default state. So if there's any configurations prior, it just resets everything. Here I'm setting the clock frequency to 16 megahertz. I2c CCR register, which is set to 100 kilohertz, and all of this stuff is coming from the datasheet. So this is the reference manual, and this is where you go all of the registers and things like that. So without going into too many of them, for example, here is the Rtc register, and we can look for some of the ones we've been using. So APB1 register, the enable register, you can see here is I2c1. There's also, for example, if I can find it. So if I just go back to this, here we can see the GPIOs. Let's delete that. So here's GPIO B, which is what I enabled, and then previously I showed you I2c1. And if we find the I2c part of this reference manual, so here's the I2c, and you can read pretty much everything from here. If I go into the registers, so here's the registers. So the software restart bit I was speaking about. So when set, the I2c is under reset state. Before resetting this bit, make sure the I2c lines are released. This bit can be used to reinitialize the peripheral after an error or a locked state. So that's why I pretty much just toggle it. There's the acknowledge bit, the start bit, the peripheral enable. So everything you can get from here. Here's the CCR register, which I spoke about prior. And then from here, it says basically how you can work out some of the calculations for it. So here I'm setting the T-rise bit. Here's the enable, so the PE bit. It basically enables the module. And then here we're getting into the actual communication functions. So basically, a lot of these are doing the same thing in a way, as in you're always checking in the status register whether a certain bit is set. So on the right byte, it takes in a byte, and it's obviously going to write it. So you say while the TX, because we're transmitting, so while that, we wait until that register is empty, in case there's something still on there. We basically load up the byte onto the data register, and then we check that the register is empty. And that same, kind of theme is for the rest of the functions. Here is the read byte, so we're reading a byte from it. As I said, if we're reading multiple bytes, we want to set the acknowledge bit to multi-byte or not multi-byte. And here we are setting the acknowledge bit. So if we're going to use multi-bytes, so read multiple bytes, then we want to set the acknowledge bit. Otherwise, we're going to clear it. And here we just wait until, because we're reading, we'll wait until the receive register is empty. And when the receive register is empty, this function is going to return whatever's on the data register. So and you'll see that also used in some of the other functions. We are on this one, it's the address, and then the _R is for read, so for reading an address. You can see here data register, so we send the slave address in read mode. So here's ADDR, and we put that on the data register, and then we wait until we received the address bit. Here is we are clearing the acknowledge bit, so after we send or receive, we get acknowledge bit depending on what mode it is in, and here we just clear it, and then we return so clear the status register 2 by reading it. So that's literally all this does. We're just reading it. This is kind of like a, I don't know, like a dummy variable, and we do this and it will clear the status register. We've got I2c address write, so for writing to the address. We can see here same, kind of like dummy variable, which we're going to reset the status register, and here we're checking the address flag, and this one is sending the slave address in write mode. Very similar functions. This is the I2c Stop to send the stop bit, and you basically just set the stop bit in the CR1 register, and as I said before, all of these are in the data sheet. So if I find the CR1, here's the start, here's the stop generation. The bit is set and cleared by software, cleared by hardware when a stop condition is detected, set by hardware when a timeout error is detected. So basically, if you want to generate a stop bit, you just set this bit. If you want to generate a start bit, it's the exact same thing. You just set the start bit, and you also check flags. So this one is checking for the busy flag, and this one was checking for the start bit flag. These were the two BCD registers, BCD functions I was talking about. One BCD to decimal, and the other one decimal to BCD. And I mean, it's pretty much, ideally, it's not a long, complicated process. Just this basically converts it into BCD to decimal or decimal to BCD. So with these functions, these are if I'm getting the seconds, and send the start bit. So where I'm getting this kind of send start address write byte start, that's from the data sheet of the DS3231. That's how this works. So if I pull up the data sheet of the DS3231, this is the data sheet, and here you can get like the slave address, which is 0x68. It's got information about like the rise time and things like that of the I2c, the pinouts. Here is the address, or the addresses, and it says all of them basically. So whether you're doing the seconds, which is on 00 address, or the minutes, etc., it's got the map of the address. And what I said before as well is that I was going to highlight that the BCD part. So it says BCD. So the time and calendar information is obtained by reading the appropriate register bytes. Figure 1 illustrates the Rtc registers. The time and calendar data are set or initialized by writing the appropriate register bytes. The contents of the time, so this part, the contents of the time and calendar registers are in binary coded decimal, so BCD format. So that's why if we're reading from it, it's going to be read in BCD, so we convert it. If we're going to send data to it, it needs to be then converted from decimal to BCD. And if we go down, we can see the I2c part. So if we're writing, so if I start, so yeah, if we're going to write, we send the start bit, then we send the slave address plus a 0, because that's what write is. And initially I did get confused about this, not for this, but like a while ago when I was just starting to use the I2c. And basically, if you look at this symbol, R obviously stands for read, W stands for write, but you can see the line above W, which basically means it's, you know, a 0 basically. So if I put a 1 here, it will be reading. If it's a 0, it goes into the write part, or the write mode. So send the start, send the slave address in, this is write mode. So you can see that here, send the start, send the slave address in write mode. That's what the W means. Then we send byte, write byte, we're going to write a 0. Why? Because we reset back to the first register in the DS3231. So that would be seconds. So there, this is the first one, which basically, if you reset back to 0, it's like a pointer basically. It points back to whichever register you sent, so 0. And we also keep note of the date, which starts at the day, which is 03, which will also be used later. So basically, following on from this, it's, you know, after you send the slave address, you get an acknowledge bit, is what we check for. You send the word address, data, blah blah blah, and it's the same, similar for the read, start bit, address, but with a 1 this time. So this is let's see, so that starts at 0 because it's the first one. Minutes is 01, the address of the DS3231, so that's why I put a 1. Write to address 2, so that'll be 02 in hex, which goes to the hours. That's what we've seen. And then it just follows the same pattern from that layout in the here. Start, address, whether you're reading or writing, then you get acknowledge bits depending on how many bytes you're sending. So as I said, these were like the older functions I used when I was first doing it, but then I used the structure. So but I mean, it's literally the same thing. You send your start, so this is getting the time. So first we write to it. Why? Because we don't know what register the let's say the I2c or the DS3231 is at. So we write to 0, right, and that will reset back to seconds. So now when we do 3 writes, or sorry, so now when we do 3 reads, we know that we're going to read from the first address. So we send the start bit, and this is actually also in the data sheet here. So data read or write, but this is sending multiple. So start, slave address in read or write, acknowledge bits, and then you put the word address, so the address you want to start reading or writing to, acknowledge bit, repeated start. So you don't have to like start and the stop, you just send another start bit and it repeat. You put the address, so in this case it will be 68, because that's the address of the DS3231, and we put it in read mode. So first we put it in write because we want to reset the pointer to point to the first one. Then now we want to read from it, get acknowledged bits, and here it's in white, so slave to master. So the DS3231 is sending to the STM board, and we'll get in data. So here, well, I don't know, you'll read a value, then you get acknowledged bit, so the master to the slave sends the acknowledged bit, and then it just basically repeats until you send the not acknowledged and the stop bit. And all of that is pretty much in here. It's very kind of repetitive. Start, address, set the pointer to, you know, the first one. We send the start again, so that's the repeated start. Then we send the slave address, and then now we're reading from the register. And here's the important part: is read byte multi-byte on. So as I said before, because there's seconds, minutes, and hours, so that's 3. So I set multi-byte on, so it basically reads again. So it'll do this one. So I set multi-byte on, it will read again. And on the last one, I set it off because we're only reading 3. So after it sends this, it's basically going to send the stop bit, which is what I do here. Same thing with the date, pretty much. Setting the time is the same, but it's the opposite. Instead of us reading to it or writing to it. So set time, hours, minutes, seconds. Start bit, address. So we're going to set the pointer back to 0 because that's where the seconds is. And then we basically wait for the register to be empty because we're going to transmit data to this. We put the data. First, we need to convert it from decimal to BCD, as I explained, previously, and we wait for the transmit register to be empty. Then we do the exact same thing 3 times. Then we send a stop bit, and that's pretty much the same thing with the date as well. So that's pretty much everything. One thing I'll point out is with the date part, the write byte, instead of 0, because we're not reading seconds, we're actually reading from address 4, which I did mention when I was showing the datasheet. So we can see here in the datasheet, I actually think I said 3, which is the day, but I'm not reading the day, I'm reading the date, so my bad. It's starts from 4. That's why I put 4. If I wanted to read the day, and any of these other registers which haven't been used, you just do this, you can literally just change it, copy the function, change up maybe some of the names, but the address you start at changes. So for the date, we actually used 4. So that's pretty much everything. Let's just see. I think I did add some comments because here I'm putting check notes, which I think is in the original file. Maybe I'll pause the recording and see if I can find it. Okay, so basically all I did was add the notes, and that basically highlights how to do some of the calculations. So here you can see like check note 1, check note 2, I think there's a check note 3 as well. So anything has a notes, especially like the calculations, sometimes they're a bit, if you're trying to read the data sheet, sometimes they're not the most clear. So I tried to explain it. So for example, in the CCR register, so clock control register, it's basically setting the speed at which you want your I2c to run at. So for here it's 100 kilohertz, and I need to put the value 80 in here. Why is it 80? If we read notes 1, to work out the value for the I2c clock in the CR2 register, do T high is equal to T low, CCR to get T high, T low. Let's keep the value the same. Yeah. In this example, T high, T low is 5 microseconds. So I got that from the DS3231 datasheet, and basically plugging all of these values in. CCR T rise. I think this is actually meant to be CCR. Sorry. So anyway, I think this video has gone on long enough. If I run this code, so if I build it, 0 errors, 0 warnings, which is good. If I load the code, and now if I put the debugger on, and that's what this main was. These variables here and in here is just see on the debugger, the values changing. So one thing is that I'm setting the date and the time, which is here. So this was at the time. So if I actually stop this, and if I set it to today's date, which is the 25th of recording, and the time is 11:27, so I'll just put 28, save that, build, and load, go to the debugger. If I run this, you can see here that if you look at the date first, 25th of January 2021, which is exactly what I put here, 25:01:21, and the time I set for here 11:28. So hours is 11, minutes is 28, and obviously seconds started at 0. So yeah, that's pretty much it for the video. You can find the code on my GitHub or blog, which both links will be posted in the description. So thank you for watching.